Hey, so here today to talk about basic statistics for the GED tests. Now you might be wondering what test you're going to see this on. What we're looking at today actually appears on three of the tests. You might see these concepts on the science test, the social studies test, and the math test. So it's really important that you understand these concepts. And whenever I'm doing a GED class, I always like to teach this first of all because you know, a lot of y'all won't stick around for a long time. And so this is one of the most important things I have to teach you, and it will help you out on the most tests and raise your scores across the board. So pay close attention. Let's check it out. So first of all, what are statistics, or what is statistics, I should say? Well, statistics is a type of a data analysis. And if you're saying, Kate, that's not any more helpful. I don't know what data analysis is either. Hold tight. We're about to talk about that. So in order to do that, let's break it down into its two words because we need to know both of those words for the test anyway. We need to know the word data. It comes up all the time. And we need to know the word analysis. What does it mean to analyze? Well, data, first of all, is just information, pieces and bits of information that you've gathered. Who gathers information? Scientists gather information. Social scientists gather information. That's why I said we're going to see this on the science test and the social studies test as well as the math test. Now, there's two types of data that you could collect. For example, I could ask everyone how old they were. If I did that, the numbers that I should say the answers that they gave me would be numbers. That would be quantitative data. It would be numerical. I say, how old are you? You answer back a number. You might say, I'm 27. That's numerical data. It's quantitative. See how it sounds like the word quantity? But that's not the only kind of data you can collect. You can also collect qualitative data. It's descriptive data. Those are words. Like, for example, if I asked you, what's your favorite color? You're not going to answer me back three. You would sound silly if you did. You might say red or blue or purple. That's an example of qualitative data. Okay. Now that we understand data, let's go on and talk about the word analysis. What does it mean to analyze? Well, analysis is just the process of looking closely at something in order to interpret it. So this is where the math comes in. The scientists and the social scientists gather the data, but as mathematicians, we can analyze it using lots of different math procedures, and we'll talk about some of them today in order to try to interpret the data, see what it's doing, what are the trends, what are the patterns. And so we'll put that together now, data and analysis, and we see that's just the branch of math that interprets information. Okay, statistics specifically, which is where we're going to look at today, is a part of data analysis, as we said. And usually when we talk statistics, we're talking a large amount of information. We've been given lots of numbers, and usually it's quantitative. Usually it's numbers. We're going to look at a few exceptions today, but for the most part, we're going to see quantitative data, and we're looking for trends. We're looking for patterns. So let's talk about different types of statistics before we hone in on what you're actually going to see on the GED. But just in general, what kind of statistics exist in the world? Well, you might see measures of spread. Don't be confused by this. What does it mean spread? We're talking about how far apart things are from each other. There's all different types of measures of spread. There's only one we're going to see in the GED. We'll be talking about that in a little bit. We might look at measures of central tendency, how a list of information behaves towards its middle. Central means middle, and we'll definitely see a lot of that on the GED. There's also measures of association, how things are related. Think fractions, think ratios, think percentages. We'll cover those topics another day. Okay. Today we're going to really focus in on a few things we're going to see on the GED. First thing we're going to look at is those measures of central tendencies that I mentioned you. We see those all the time in the GED, probably one of the most common type of problems that occur. And so we've got to be familiar with them back and forth. So you should know there's three types of measures of central tendency that we're going to be looking at. And they are the mean, the median, and the mode. A lot of you guys have heard of them before. And so sometimes students tune out on me right here. They say, I don't need to know this. stay tuned for me, please, because I see two problems in most students. One, you guys mix up which one's mean, which one's median, and which one's mode. So I'm going to be giving you some tools and tricks to help you remember the three today. But also, um, what I find is that most students, even when they do know this concept, only know how to do the straightforward problems. So as we go through, and we'll do individual videos on each mean, median, and mode, but we're going to look at some GED trick problems. You're not going to see a lot of straightforward problems on the GED. Most of them involve thinking things through a little deeper than you usually would. So we're going to look at the type of problems you will see so that you aren't fooled. Okay. And then the only other thing we're going to be looking at today is range, which is one of the measures of spread and the only measure of spread that we're going to see on the GED. And like I said, we'll leave measures of association for another day. But range is something we're going to look at today. So first, before we move on, I just want to talk about what are these measures of central tendency. So basically, we already said, what does the word central mean? It means the middle. What's a tendency? Well, think about it. If I say, Janet, she has a tendency to be on time for class and be prepared, what am I saying? I'm saying that's Janet's usual behavior. That's what I expect of her. That's how she usually acts. So when I talk about measures of central tendency, I'm talking about the way the center of a list of numbers behaves or acts, the trends, the patterns I see towards the middle. Okay, so three different ways to look at the middle of the list of numbers, okay? You probably already figured out their mean, median, and mode. But let's look at them one at a time. So mean, first of all, what is mean? You should know, you've probably heard of this before, it's the average. If you've ever heard the word average, that is synonymous with mean. But you might not understand what it is exactly. What an average or a mean is it's the amount you would all have if the world was absolutely fair, if the data was spread out perfectly equally. Imagine that you polled 100 students and asked them all how old they were. They're going to tell you different ages. One might be 13 and one might be 25. But the means what it would be if they all shared their ages equally, if they were all the same age. So we're looking at an evenly distributed data. Now, how does that compare to the median? What is the median? Well, the median, think about it. You know this word. If you drive, do you drive anywhere? There's a median in the road. When we're driving, where do you find that median? It's the middle of the road. And so just like in life where the median's in the exact middle of the road, we see that as a placement thing when we're talking data analysis as well. The median is the centermost number, the number in the middle, perfect middle, like in placement, of an ordered set. That's super important. I underline the word ordered for you here because this is where most students screw up. The list has to be in order before you could ever find the median. Or as I joke, the road has to be built before we know where the middle of the road is. Okay. The last measure of central tendency that we're going to look at today is the mode. Mode is a word, if you speak any Latin-based languages like Spanish or French or Italian, you might be familiar with this concept of mode. It means to be fashionable or trendy, and it's the same here. The mode is the number that happens all the time. It's the one that happens the most time. And so I have for definition for mode, it is the most commonly occurring item in a data set. If most of the students in my class are 15, then the mode is 15. If most of the students are 25, then the mode is 25. We have three different ways of looking at the middle of a list. When is it good to use one way, when another? So we need to talk about that. In fact, you could be tested on that on the GED. You could be asked, what is the most appropriate measure of central tendency here? If you don't understand a little bit about these concepts, you're going to be in trouble. So let's compare mean, median, and mode side by side here. Let's start with mean. Okay, so we already talked about what mean is. It's what we'd have if we all shared it equally. But one thing you should know is mean is very common. Mean, or as we said, it's also average, is used quite frequently. In fact, I would go so far as saying it's the most frequently used measure of central tendency. So if you completely forget everything I ever taught you today and you just have to pick one of them, a good choice would be the mean. It's usually the right answer. Usually appropriate. Let's talk about some exceptions though. There's always ifs and buts, right? So in this case, there's some big buts. So some excepts when you wouldn't want to use mean. One of the times is when you have an outlier. Do you know what this word means? What's an outlier? Well, we've been talking about data, data being sets of numbers. Um, an outlier is when you have a number that's much larger or much smaller than normal. It doesn't have to be just one, it could be a few, but they're so different from the rest of the list that if you pulled the mean, it wouldn't give you an accurate representation of what's really going on the list, because that really small number or that really large number would skew the sharing that we would have to do with mean. And we'll talk a little bit more about that later, but for now, let's look at the next thing. When you have qualitative data, you wouldn't want to use mean. It doesn't make any sense. Well, you better remember what qualitative data is. We just talked about it a few slides ago. Qualitative means words. So if I asked a bunch of students, what kind of animal or what kind of pet they have, and they said turtle, dog, you know, I've got a hamster, I've got a gerbil. And then I said, well, what's the average of your pets? What are you going to say? What's the average? Like, I don't know, like mostly dog, a little cat? That doesn't even make sense. So when the data's words, not numbers, we're in trouble. Mean won't work out for us. We're going to need some other tools. So this is when median and mode come into play. Let's take a look. Median. What are we going to use median for? Median is very useful when you have those outliers we talked about. We've got really big numbers or really small numbers. They're just because they're huge, they're going to be on either end. So they won't affect the middle as much as they would if we took the average. We started sharing equally. Okay, so median is more appropriate when we have outliers. Good example of this, you've probably heard this phrase. We do median home prices. Why? Because in our neighborhoods, there are going to be hundreds and hundreds of houses that are around a middle. Maybe it's $100,000 houses are the normal in our neighborhood, but maybe there's those $3 million homes. Those $3 million homes are not the normal. And if we factored them in using mean, they would make it all seem like we had much more expensive houses than we did. So median would be a much more appropriate choice in a case like this. That's not the only time we see outliers. We also see it with income. Same deal. Most of us make, 40, 50,000 a year if we're lucky. But then there's those occasional people that we all hear about and dream of becoming, right, who make millions. Yeah, and we don't want them affecting the middle of the list, and so using the median will help make them not have as big of an effect. And I put this with a question mark because sometimes median is more appropriate to measure the age in a GED class. Why? Because most of my students in a GED class, I'll have a lot of 16-year-olds, I'll have a lot of 20-year-olds, I'll have a lot of 25-year-olds. I don't generally have a lot of older students. That being said, I've had students who are in their 80s. If you have one 80-year-old student in the class, he could really skew the mean, and therefore median would be more appropriate. Mode. When do we use mode then? I haven't even brought that up. Let's take a look. So one thing you need to know, and this is a big GED trick they love to do, mode is the only appropriate measure of central tendency when the data is qualitative. When we have words, the only thing we can talk about which word happened the most. You can't find the average. You can't find the median because they're not numbers. Your only option is mode. So if your data is words, you'd better choose mode. Another thing is when you have a lot of repetition in your data, you've got the same numbers happening over and over and over again, especially if it's one number happening over and over and over again. Mode might be a better choice than mean or median in a case like that. It's whenever you want to describe most of the data, you're like, well, look, most of the numbers are this number, or most of the words are this word. Now mode is appropriate. Hope that makes sense. Let's go on. And let's look at some sample GED style problems where you might have to choose for yourself, mean, median, or mode. Okay, first one. Example 1, we have this little word problem we've been given. It says all the students at Parker Elementary School were asked their favorite color. So the data that we're getting, it's a list of colors. The results are summarized in the frequency table below. Which measure of central tendency would best represent this data? Now, pay attention here. Notice what our data is. Our students answered with words. They said red, orange, or yellow, or green. They didn't answer us with numbers. Our data is in the form of words. Don't think that over here, this right-hand column, number of students, is my data. That's not my data. That's me being too lazy to write the word red 17 times. A frequency table tells us how many times we got the same piece of data. So I got the word red 17 times. I was told the word orange by a student 6 times. And it's a great way to summarize a lot of data in a small amount of space, but make sure you understand what that means. Okay? So if I'm looking at which measure of central tendency would best represent this data, there is only one choice. My data is qualitative. It's words. I can only do one thing, and that's find the mode. You might say, well, which one would be the mode? Well, which answer was given the most times? Really easy. If you look at these number of students, you're going to see that the one with the highest frequency here, the most students, is blue. And so therefore blue is the mode of the list. Don't be like my confused students who tell me the mode is 26 because 26 is the highest number. 26 wasn't part of the data. It needs to be a part of the data. Blue was one of the answers I was given to my question, what's your favorite color? And it was the answer I was given the most times. I hope that makes sense. Okay, let's move on to the next example. So again, I see a chart. This one's a little different. Let's read this. Example 2. The data below shows the high temperatures in Phoenix, Arizona for each day of June 2016. And y'all, I went and looked this up, okay, because I'm so glad not to live in Phoenix anymore. These were the real high temperatures. Whew. Yeah, be happy we're in Yavapai County, right? So what would be the most appropriate measure of central tendency to represent this data? So again, it's really important to be able to look at your chart and know what your data is. What were we recording? We were recording high temperatures. So our data is going to be all these columns of high temperature, not the dates. So let's examine this data. Take a look at these numbers. I don't see a single number repeating over and over again. I don't see any huge outliers, like there was no day that it was 200 degrees or negative 20. All these numbers are varied and they seem to be in a reasonable range. This is a normal data set. This is a time when mean is appropriate. So we would just go ahead and find the mean or average of all the temperatures. So there you go. With qualitative data that has no significant outliers and no significant repetition, we're just going to go ahead and choose mean. That's the normal. I do want to point out, though, that there's nothing wrong with finding the mode or the median of the set. You could find all three if you wanted to. All three are great. Okay. So, another example. Let's take a look at this one. Example 3. Kate used to teach algebra to freshmen. True story, y'all. So glad I teach adults nowadays. But anyway, I did used to teach freshmen. One day, she asked her students their ages. Now, you know, in a class, a high school class, the numbers are really close together. So the list of numbers they get below represents the answers they gave. Take a look at this list of numbers. What do you see? 14, 15, 15, 15, 15, 16, 15, 15, 14, 15, 15, 15. There's a lot of 15s in this list, aren't there? In fact, I would go so far as to say that most of my students were 15. And in fact, that was the case, you know. And so that being said, if most of the students are the same age, well then the most appropriate measure of central tendency is mode. And that's what I would use here. Most of the students are 15. In fact, I counted 20 out of the 28 students in this list were 15. So with that much repetition and such a small range, I'm going to go ahead and say most appropriate choice is mode. And yeah, the translation of that, what does that mean to us? Most of the students in the class were 15, which makes sense. Okay, last example here. Example 4, Ron Traditional School would like to highlight the dedication and experience of their teachers. Which measure of central tendency would best represent the years their teachers have worked at the school? So we're looking to represent the years their teachers have worked. So better take a look at this column. Here's our data, years at Ron School. Now you can see most of these teachers here have been teaching a really long time. But look at that. Mrs. Bliss. Mrs. Bliss has not been teaching very long, only a year. And we have a problem with her. If we throw her in and do a mean, evenly distribute data, Mrs. Bliss is going to take years from a lot of the other teachers, making it look like these teachers have taught not as long as they actually have. Mrs. Bliss is an outlier. Do you remember which measure of central tendency we use when we have outliers, really small or really large numbers? The best one to use is median. So because all that data is fairly close together, I would go ahead and use median rather than mean. Okay? So I tried to stop this video too early and not talk about range, but I'd caught myself. I promised I would, so let's do that. So remember, though, that range is not one of the measures of central tendency. We're not going to group it with mean, median, and mode. Those are ways of looking at the middle of a list of numbers. Range, we said, was a measure of spread. When we're talking about range, we're talking about how far apart the numbers are. Okay, so we need a definition here. I got a definition for you. Range is a measure of how spread out the data is. Or another way to put it, it's the difference between the highest and lowest items in the data set. Okay, the difference, that's a big math word. That's a big math word. Do you guys remember what that means? Do you even know what that means? And if you don't, take note of it. Make yourself a little note here. Difference means subtraction. Okay, let's take a look at a few examples. We're not going to mathematically do some range problems, but I just want to be able to compare ranges for you. So we're going to look at a data set, and this particular one is probably pretty typical of a high school math class maybe. And so my question to you is just, does it have a small range, or are we looking at a large range? Are the numbers close together, or are they spread apart? If you look at this, here's my data set. You're going to see a bunch of 15s, a few 16s, a couple 14s, and then just one 17. So clearly the data here is really close together. Everyone is close to the same age. We have a small range. And oh my gosh, look, I have a typo. Y'all can correct it in your notes. But we can see these are very close together. They range only from 14 to, not 16, but 17. So our range here is relatively small. Now, on the other hand, you can see the ages in a typical GED class. You're probably going to see a larger range because when you see the ages in the GED class, they're more spread out. 16, 28, we got a 56-year-old in this particular class, a 45-year-old. See those numbers further spread apart. This particular set has a much larger range. The class ranges from 16 all the way to 56. We see a much more significant difference in the ages on a larger spread. Okay, great. So I hope that made sense to you. I want to encourage you to go on and watch the videos for each mean, median, mode, and range. You need to be able to do all four of those mathematically, and I'm going to show you lots of tricky GED examples that will enable you to do your homework, but also to do well on the GED Science, Social Studies, and Math tests.